Second quarter week 4 to 5 subject. Science 8 most essential learning competency. Explain how earthquake waves provide information about the interior of the Earth. Lesson title. The Earth. Layers of the Earth. Inner core, outer core, mantle, crust. The Earth. Earth is the third planet from the Sun and the fifth largest planet in the solar system in terms of size and mass. Its single most outstanding feature is that its near-surface environments are the only places in the universe known to harbor life. Tsunami is a sudden push from an underwater fault can produce a wave. Unlike a wave that is formed by the wind, a tsunami is so much more powerful. Wind waves are just sea surface waves. In comparison, a tsunami involves the whole depth of the sea, from the seafloor to the surface. Far from the shore, a tsunami is low, maybe just a meter high. But it travels at the speed of a jet plane. When that tsunami reaches the shore, it slows down but it grows in height. So, how are earthquakes related to tsunamis? When a fault suddenly moves on land, you experience an earthquake. But if a fault suddenly moves in or near a body of water, you may experience a tsunami in addition to the earthquake. Thus, when you are near the sea and you feel a strong earthquake, treat that as a warning signal. Run to the highest place you can find, or if you have a vehicle, evacuate inland. Not every fault movement beneath the sea will produce a tsunami. Those faults that move in a horizontal direction or sideways will not result in a tsunami. The faults to move in the vertical direction. In this lesson, you will learn how earthquake waves that provide information about the interior of the Earth. Main types of seismic waves. Main types of seismic waves: body waves and surface waves. Underbody waves are longitudinal or P waves, transverse or S waves. Undersurface waves are Rayleigh waves and love waves. Body waves refer to the vibrations that travel through the interior of the Earth. Two types of body waves. 1. P waves, is the motion of P waves. Primary waves or P waves push rocks in the direction they are traveling and they travel in all states of matter. The P waves that go through the center of the Earth rise faster than those that pass through the center. 2. The S waves movement. S waves displace rocks at right angles to the direction they are traveling. This kind of wave cannot pass through liquids. Surface waves refer to vibrations that travel at the surface of the Earth. They can also travel at the surface of the mantle and core. From this diagram, red waves represent the S waves, while the yellow waves represents the P waves. Two types of surface waves. First is the Rayleigh waves, the second one is the love waves. 1. This is the motion of a Rayleigh wave. Rayleigh wave is the type of surface acoustic wave that travel along the surface of solids. They can be produced in materials in many ways, such as by a localized impact or by piezoelectric transduction, and are frequently used in non-destructive testing for detecting defects. 2. Meanwhile, this is the motion of love waves. Love wave is named after Augustus Edward Hooke. Love are horizontally polarized surface waves. The love wave is a result of the interference of many shear waves, guided by an elastic layer, which is welded to an elastic half-space, on one side while bordering a vacuum on the other side. Learning Task 1. Using the given organizer, write the necessary information, to complete the concept about seismic waves. Get ready as your teacher calls you to recite. Learning Task 2. Prepare a basin with half-filled water and stone. Drop a stone into the basin, and observe what will happen. Questions. Number 1. What happens when you drop the stone? Number 2. What causes the ripples to form? Number 3. How far does the ripple continue? Get ready as your teacher calls you to recite. The vibrations are more properly called seismic waves. As seismic waves travel through the body of the Earth, They behave in different ways, depending on what they encounter along the way. The figure shows seismic slinky, modeling P and S waves in the classroom. Learning Task 3. Use a slinky wave in this activity, and answer the given questions. Note: you may use unused notebook metal spring as alternative if slinky wave is not available at home. Procedure. First, prepare a slinky and a masking tape. Second, mark a spot on their slinky near the center with masking tape at the top of the loop. Third, ask someone from your family to hold each end of the slinky. Stretch out the slinky along a table. Lastly, take turn in compressing 15 coils, and then releasing them rapidly, while they hold the end of the slinky, making sure to observe the energy wave travel the length of the slinky. Guide questions. Number 1. Describe your observations of the coil and tape. Number 2. What kind of seismic wave does this slinky motion represent? Get ready as your teacher calls you to recite. Learning Task 4. Read the instructions found on the next page. Then, answer the questions. Material: 12-inch flexible plastic ruler. Procedure: first, hold the ruler horizontally at both ends. Then, bend the ruler. Question 1. Do you feel the ends of the ruler pushing against your hands? Now you can release the ruler. Question 2. What will happen to the ruler as you release it? Now, hold one end of the ruler firmly with your right hand, and bend the ruler again, with your left hand. Question 3. What was stored as you bent the ruler using your left hand? Finally, while keeping a tight grip with your right hand, take away your left hand quickly. Question 4. What will happen to the ruler as you take away your left hand quickly? Get ready as your teacher calls you to recite or submit a picture holding the ruler, just like in the picture. Learning Task 5. Create a wave box that demonstrates how earthquake waves can travel through a variety of materials, as they travel away from the focus of an earthquake, where the rocks first rupture. A wave box. Materials: box, string, paper clips, iron nail or Paco. All earthquakes produce P waves and S waves. P waves travel through solids, liquids and gases. In this simple science experiment, you will see how P waves travel through different solids, causing paper clips on a string to vibrate. Procedure. First, remove one side of a cardboard box. Second, punch a hole in the top and bottom of the box using an iron nail. Third, tie a string so it runs from the top of the box to the bottom of the box. Fourth, start by tying a string to a paper clip on the outside of the box at the top. Fifth, thread the string through the bottom of the box and tie the string to a paper clip on the bottom of the box. Sixth, place 4 or 5 paper clips on the string inside the box. Seventh, place the box on a table or some other object you can strike to make it vibrate. 8. Strike the table hard enough to cause energy waves to travel through it to the box. 9. Move your box to another surface and see if you can make the paper clips vibrate on these surfaces. 10. Change the experiment by using a different thickness of string. Lastly, change the experiment by using different sizes of paper clips. Guide questions. Number 1. What will happen to the paper clips if you have struck the table hard enough? Number 2. Why does vibrations create sound? Criteria for simulation: excellent, 5 points, proficient, 4 points, adequate, 3 points. Under criteria, we have details in simulation, method of presentation, techniques, creativity and accuracy. Get ready as your teacher calls you to recite or submit a picture holding the wave box. Learning Task 6. Choose the letter of the best answer. Number 1. Which layer of the earth contains rocks that are moving slowly but continuously? A. Crust, B. Mantle, C. Inner core, D. Outer core. What is the correct answer? The correct answer is letter B. Mantle. Number 2. What happens to the P waves when they are approaching the molten part of the Earth's interior? A. Become slower. B. Remains the same. C. They disappear. D. The velocity increases. What is the correct answer? The correct answer is letter A, become slower. Number 3. What do you call the region on Earth's surface where a violent earthquake is felt? A. Crust, B. Epicenter, C. Focus, D. Plate tectonic. What is the correct answer? The correct answer is letter B, epicenter. Number 4. Which of the following seismic waves is detected first by the seismograph? A. L waves, B. P waves, C. waves, D. S waves. What is the correct answer? The correct answer is letter B, P waves. Number 5. Which government agency in the Philippines monitors the earthquake? A. DOST, B. DEN, C. NDRMC, D. FIVOLX. What is the correct answer? The correct answer is letter D, FIVOLX. Number 6. Which layer of the Earth is said to be solid? A. Crust, B. Mantle, C. Inner core, D. Outer core. What is the correct answer? The correct answer is letter A, crust.